I like, yeah, distribute or everything times everything. That's all this is, just distributing. Everything in the first set of parentheses needs to get multiplied by everything in the second. That's it. So let's do this here. When I'm multiplying these out, I like to put them in exponential form first. That's just how I like to do it. I think it's helpful. So this would be 2y to the what power? 1/3. 1/3. 4 times 2y to the 1/3 plus 1. I like doing it. It's the same thing. All just gone from radical form to what? Exponential. To exponent form. Exponential. Yes. So if I keep going here, I need to multiply. So if I multiply those two things, I end up with 4 times 2y to the what power? No. What do you do with the powers? You add them. So what do you get? 2/3. Exactly. Good. And then you do the next one, and you end up with plus 2y to the minus 20 times 2y to the what? 1/3 minus what? Okay, so what can we, there's two like terms there. Which two terms can we combine?
4, 2y, and 2y.
The powers have to be the same.
Oh, the 4, 2y to the 2.
No, this is 2/3. The powers have to be the same. So it's 4 times 2y minus what? How many of the?
18.
Nope. There's one of them here. Minus 19, 2y to the minus 5. Done. There's nothing more you can do. Leave it there. I like that. That would be clear. That would be as far as you can go. You can't combine anything else. Why can't you combine anything else? No. Why? The powers are different. They're not. There's no like terms anymore. The powers are different. Yes.
60.
That would be 4 times the cube root of 2y parentheses square minus the cube root of, or 19 times cube root of what?
2y.
Cube root of 2y. It's not squared there. Oh, it is, because it's 1/3. It's 2y to the first, right? Minus 5. Do you see where I'm putting those numbers there? Like this one up here. See this one? Where'd that go? That's the first power. Do you usually write the first power? No, but I'm just showing you why it's only raised to the first power. But then on the other side, what do you have? A 2/3 power. That's where the 2 is. Does that make sense? Okay, so Noah, you asked about number 60. The denominator. So what do we multiply this by? Square root of m over the square root of m. Why are we allowed to multiply by this? Because this is what? Form of 1. So what does this equal? Negative 4 times the square root of what?
13m.
Yep. All over m. Because the square root of m times the square root of m is what? M. Yes, you're right. That's great. Actually, that's totally fine for an answer. The square root of m times the square root of m is a table. I'm totally with you on that logic. It's the same thing no matter what. The square root of 8 times the square root of 8 is 8. The square root of negative blah 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 times the square root of negative blah 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 is negative blah blah blah. It doesn't matter what's inside.
So the negative goes with it.
Yes, exactly. So if you had like the square root of negative 4 times the square root of negative 4, what does that equal?
Negative 4.
Yes. Absolutely. Any other questions from 8.5? First big step, isolate the radical. Is the radical isolated? What do you subtract from both sides? So 5k minus 3 is equal to? What do you do to both sides now? So you end up with 5k minus 3 is equal to what?
Positive 4.
Positive 4. So you have 5k is equal to 7. 7. So k is equal to? 7 over 5. What do you have to do? If you check this, you end up with the square root of 5 times 7 over 5 minus 3. Plus 2, does that equal question mark 0? Here's the thing though. You have the square root of what? 7 minus 3 plus 2. The square root of 4 plus 2. What's 2 plus 2? 4. So is there an answer? No. So there are no solutions.
I got no solution, but I got it wrong.
Okay, well then that's better than wrong, but you need to have the right.
It's because I put negative 4. That's where
It's definitely positive. So here's the thing. You can kind of see it coming though, right? If this equals 0 and this is positive, what does this have to be? Negative, because to get this to be 0, you have to be a negative plus a positive is 0. This is like negative 2. Is it possible for this thing alone to be negative? No. This is positive. What's the smallest value this can take? 0. Because you can't make it negative. Like if I plugged in 3/5, what's 3 minus 3? 0. The smallest thing this can be is 0. So what's the smallest the whole left side can be? 2, because there's a 2 right there. What's it's 2. So that one, there are no solutions. Does that make sense?
Yeah.
So do you really, really got to check these? Yeah, you really do. You really do. What's that first step? So what should I add to both sides?
9.
No, you subtract 9.
You either subtract 9 or what do you add?
Add the radical.
Add the radical. So you get 9 is equal to, does it matter what side it's on? No.
I like that it's both possible.
Yeah, and that's what I would do because it reduces the number of negative signs. What do I square? Although when I say the answer first. What do I do to both sides? Square.
81.
81 is equal to?
4 plus 1.
So 80 is equal to?
4.
So 20 is equal to x. What do you do with this?
Plug it in.
You check. And do you see that? I like doing this. 9 minus the square root of 4 times 20 plus 1. Does that equal 0? Well, that's going to be 9 minus the square root of 81. That's 9 minus 9 does equal 0. So does it check? Yes. So this works. Make sense? What's your next one? Okay, any others from 8.6? On the first one here, what do you do to is the radical isolated already?
No, oh, yeah.
Yeah. So you just go straight into squaring, and what do you get? 9 minus x is equal to x plus 3 times. So you have to make sure you don't just square each thing. You write it out again. X squared, you end up with 6x plus 9. And then you end up with 0 equals x squared plus 7x. So 0 equals x times. So x is equal to 0 or x is equal to. So then literally on your test, write check. I like this because it keeps it separate and it makes it so that you understand what you're doing and why. So then you plug in 0. So negative 9 minus 0, does that question mark equal 0 plus 3? Square root of 9, does that equal 3? Well, 3 does equal 3, so 0 works. Then what do you plug in? Negative 7. So you have 9 plus 7 equals negative 7 plus 3. So it's the square root of 16 equals negative 4. Does 4 equal negative 4?
No.
No. So this one is not a solution. Then you'd be done. We did one like this last class. This is challenging. Why is this one challenging? Yes. There's 2 radicals.
And you can't have a radical and make the same thing.
Well, you could. It's just I'm just giving you a path that makes it easy. So the structural thing, the structural element that makes this more challenging, it has 2 radicals that you can't combine. R plus 6 and R minus 2 are different radicals. So I gave Noah a hint. It's much better to put them on opposite sides. So we end up with the square root of x plus 6 is equal to 2 plus what?
R minus 2.
The square root of r minus 2. At this point, what is the only thing you can do at this point?
Square the equation.
You have to square both
Side.
sides. So go back to the board, everybody, and keep going from this step.
I had it before.
So you can rewrite this as, you can get rid of that little square sign to make it, and I'm stuck on erase, 2 plus the square root of r minus 2. So what does the left side become?
R plus 6.
Just r plus 6. But the right side becomes 4 plus 2r minus 2 plus 2r minus 2 plus what?
R minus 2.
R minus 2. There are 4 things there. Which 2 can we combine?
The 4 and then negative 2.
We can combine this one and this one, right? And there's other ones too. And, sorry, you're right, you're absolutely right, sorry. We could, the 4 and the minus 2. And what can we subtract from both sides?
6.
The r.
Oh.
So what do we end up with? 6 is equal to, what do we end up with? What's this and?
2 plus
2 plus?
4 square root r minus 2.
Yes, Gabby, very good. Now what do I subtract from both sides? 2. So I end up with 4 is equal to 4 square roots of, what can I divide both sides by? 1 is equal to the square root of r minus 2. What do I do to both sides? Because the radical is isolated. Square both sides and you get 1 is equal to what?
R minus 2.
So what does r equal?
3.
3. It become really nicely. What does the right hand time? Just becomes 3p plus 2.
Oh, why did I add the 3 to both sides?
Okay, so you could, it's fine. You can add the 3 because it makes there be less negatives. What's a square root of a table times the square root of a table? So it's going to be 3 minus 3p. And then you have how many of them? Sorry, I missed it. Going to this one right here.
3
Negative 3 times this. And then what do you get?
minus
Minus 3. Oh, same thing. And what's negative 3 times negative 3?
Positive 9.
Equals 3p plus 2. Okay, so what can we combine on the left side? There's a 3 right here and a 9 right there. What does that become? Becomes 12. So we've taken care of those. Minus 3p minus how many of these do we have? 6 of them. And we haven't done anything to the right yet. What should I add to both sides? 3p. So what do I end up with? 12 minus 6 root 3 minus 3p is equal to what?
6p.
Plus 2. We haven't combined everything we can. We need to isolate the radical if we can. What should I subtract from both sides? Subtract 12. And you end up with negative 6 times the square root of 3 minus 3p is equal to 6p minus what? 10. At this point, you could divide by negative 6, but we don't really want to do that. Why?
Because you're going to have
You get fractions all of a sudden. So you can, at this point, you can just square both sides. If you square both sides, you have to square both sides, not individually square both sides. So if I square this and I square this, do you see how I put those parentheses around the sides? What does that mean? You have negative 6 root 3 minus 3p times what? Negative 6 times 3 minus 3p equals 6p minus 10. Exactly. What does the left side become? What's negative 6 times negative 6?
36.
36. And what's the square root of 3 minus 3p times the square root of 3 minus 3p?
3 minus 3p.
Yeah, a table. Equals 6p times 6p is what?
36p squared.
Yep. Minus 60p plus. Is it kind of annoying that these numbers are bigger? Yeah, but they could be worse. What's 36 times 3? 108.
I was getting there.
You were good. 18, I heard you. It's good. Equals 36p squared minus 120p plus. You have a quadratic now, so what do we want it to equal? 0. Because once it equals 0, then what can we do?
Check.
Factor.
Oh.
We make it equal 0, we factor and solve. Then we check. Make it equal 0, factor, solve, check. So what do I subtract over here? 108 minus 108, and what do we add? Plus 108p. So we end up with 0 is equal to 36p squared minus what? 12p minus
8.
8. Good. Now all of those coefficients are what type of numbers?
Positive.
They're no, because
It's not positive.
they're not positive.
Real
I know they're real. That's fine. They're not. They're even. What's the biggest factor? Bigger than that.
4.
This is 0 equal to 4 times 9p squared minus what? 3p minus what? 2. What can we divide both sides by?
4.
4. What's 0 divided by 4?
0.
So we have 0 is equal to 9p squared minus 3p minus 2. At this point, what do you have to do? You have to factor. And what's the one thing that's kind of annoying about this one? What's one number there that makes you kind of sad?
The 9.
The 9. Exactly, Sarah. You don't like the 9, but don't be hating on it too much because it could be worse. I could give you like 32 as a leading coefficient, and then you'd be real sad.
2 is prime.
2 is prime, so there's limited choices for the second pair. So we know this is going to factor into, assuming we've done all the work correctly. What do we have? 0. Hold on a sec. We're 3 minus 3 negative 1/3 minus 3. Does that equal the square root of 3 times negative 1/3 plus 2? What's that come down to? That's going to be 3 plus what? 3 plus what? Minus a negative is what?
Oh, positive.
So it's 3 plus 1 minus 3. Does that equal? Well, that's negative 1 plus 2. So this is the square root of 4 minus 3. Does that equal the square root of 1? 2 minus 3, does that equal 1?
Yeah.
Does it?
No, it equals -1.
Does negative 1 equal 1?
Oh.
No, it doesn't. So this right here,
Come on.
not a solution.
We should get like 2 of these for homework.
Oh no, on this kind of question, I would never give you like more than 1 of this difficulty level on a test. No, this would be a last one. What's the other value we have to test?
6 points.
Kids, What's the next value we have to test?
The other,
2 over 3 into both sides, right? So we have the square root of 3 minus 3 times. Kids, if you can't be quiet, I will give you the test 2 days early. 3 times 2/3 plus 2. What does this come out to be? The square root of 3 minus what? 3 minus 2 minus 3. Does that equal the square root of 4? We have the square root of 1 minus 3 is equal to what?
Equal to negative 2, and that equals 2, so no, there's no solution.
Does this equal? So, it's kind of disappointing, but guess what? No solutions.
After all that work
Yeah.
for nothing.
Yeah, no solutions.
We've gotten the same results if we wrote down a bunch of random numbers.
Can I tell you why? Yeah, can I tell you why that's true? I mean, well, not why that's true, but I'm, at this point, the only thing that's in my head right now, well, two things. One, this is a ton of work.
we definitely did something, I feel like,
What could we have done?
added.
We could have like made a mistake in one little place. The thing that makes me feel better though is when you get no solutions as your answer, it's going to be because you get things like this. Does negative 1 equal 1? No. Does negative 2 equal 2? That's exactly the type of no solution endgame you want to see. What would make me worry more if it said like 5 equals 9? You'd be like, well, that's definitely not true. But that's not the kind of error you see. This is the kind of error you see. And yes, I understand that it's really kind of like, no solutions. But the point is, the answer is no solutions. And you've proven that there's no solutions. You've proven that there's no solutions. Is it really possible that there's an error somewhere in here?
Yes.
Absolutely. Yes, David.
If on a